Hey guys, let's take a look here at the CFA answers for CFA 1 here in Unit 4 from lessons 4.1 to 4.4. And at the beginning here, we're going to write each expression or number using an exponent. So on the first one here, we know the base is 4. So 4 is my base, and I know there's 3 of them multiplied together. So that's 4 to the third power, which means 4 times 4 times 4. On B, kind of have to undo this a little bit here. Some of you would think of square root when thinking 8 times 8 equals 64. So you could have 8 squared or 8 to the second power. There's some other answers that can get you to 64 with exponents too. You could have 4 to the third power. 4 times 4 times 4 equals 64. And there's one other one I think we could get 2 to the sixth power. If we do that, that also would equal 64, but I think the easiest one, knowing your facts, 8 times 8 is 64, so 8 squared. Question C, we've got the base here. Let's kind of see there's a kind of covered up here with the light, but there's another 3.12 here. There are 5 of them. So the base is 3 and 12/100ths, and that's to the 5th power because there are 5 of those. And then 1/16, if you think of the square root of 16, is 4. 1/4. And remember, we have to put that in parentheses, guys, because we want to take that whole thing to the second power here. 1/4 times 1/4 equals 1/16. There is one other way we could take a look at doing this. You could also say 1/2 to the 4th power would be another way you could get this. 1/2 times 1/2 times 1/2 times 1/2. If you have 4 of those, that's also 1/16. So a couple of different answers there that would work for that. Okay, and again, I'm going to be scrolling up and down here, so we'll pause this if we need to. If you're at home, pause it. Make sure you get these answers written down here. Then we'll move to the next one. All right, on the next one here, we've got word problem here where Mr. Botch displayed the expression 33 times 2 minus 12 divided by 2 for his math class, and he simplified this expression, followed those order of operations, and he came up with the answer 27. That is not correct, so we're supposed to show the correct answer here. So if we rewrite 33 times 2 minus 12 divided by 2, we can take a look at the order of operations, and we like to follow the PEMDAS model. Remember that it stands for parentheses first, then exponents, then multiply or divide left to right, and add or subtract from left to right. So if I'm following this, there are no parentheses or exponents, and I know I need to multiply or divide from left to right, whatever I run into. So I run into 33 times 2, which is 66. And we like to stay organized, so we're going to make that upside down pizza slice or upside down triangle, stay organized. I like to rewrite the whole thing after that, and this is what we have left. And we start over going multiply or dividing still from left to right, so I do not do this. There's a division, so I do that first. 12 divided by 2 is 6, and rewrite. So I'm left with 66 minus 6. So I've done parentheses, exponents, I've multiplied and divided, and all I have left is this subtraction. So I'm left with 60. And again, I made that pizza slice, that upside down triangle there, and I know my answer should have been 60. So on B, they want us to rewrite this expression using parentheses to show how we could get that answer of 27 that Mr. Botch came up with. Okay, so I'm going to scroll up here and erase. So again, we'll make sure we pause if we need to. And you can rewrite this. All right, so how could he have gotten the answer of 27? 33 times 2. Check the problem here. 33 times 2 minus 12 divided by 2. So we've got it rewritten here, and you guys would have to play around with where to put the parentheses. One thing I know, I wouldn't put the parentheses here because we know we multiply first anyway, and I wouldn't put it here because I also know we'll do that next. So some of you might have to put it around 2 minus 12. That would come up negative, so probably not since we haven't studied that. We talked about how you can put parentheses around 3 numbers, and inside your parentheses you have to follow the PEMDAS rules, so I'd multiply first. So if I do this, I'm left with 33 times 2 is 66, minus 12, and divided by 2. And by putting those parentheses there, it gives me permission to subtract first. So 66 minus 12 is 54. Done with that. Now if I take 54 and cut it in half, I get 27. So that would have been what Mr. Botch was doing, but he did it without parentheses, so he didn't follow the order of operations. To come up with that answer, you have to have parentheses here. So get that rewritten, and we'll move on to the back side. All right, so we're talking about growing patterns here on this problem. I notice there's one dot here, and here there are 8, and 9, 18, 27. So we're seeing this growing pattern here, and it looks like they're adding more dots every time to the rows, and they're adding more of the rows. And these are kind of tough trying to find that pattern. In this case, I'm seeing now, sometimes as you start to recognize numbers, you'll see that these numbers are to the third power. I'm seeing a pattern here that we have multiple rows. See how I go from 1 and then to 4 and then to 9. So when I see 1, 4, 9, I'm thinking 1, I have 1 squared. To get 4, I have 2 to that squared, or 2 to the second power. To get 9, I have 3 to the second power. So I'm starting to see, to get those, I could do some things with squaring. But then I have 3 rows of those. And here I have 2 rows of this 4. Here, I don't have any more, but just that 1 row. So there's different ways you could look at this. My brain originally sees that I have some square numbers, so I'm going to use that. Step 1, I have 1 squared, which gets me that row, and I only have 1 row. So I can have 1 squared times 1. Here, I have 2 squared to get me 4, but I have 2 rows of those, so again, I'm taking it times 2. So really, you're taking 2 times 2 times 2. So does that equal 2 to the third power? Or this is 1 to the third power, 1 times 1 times 1. So I'm finding that pattern. I get to the third one here. I'm going to write this on the outside because the light's showing on there. But the third one, to get this first row, I have 3 squared to get 9, and then I have 3 rows of that. So times 3, which really is 3 to the third. So step 4 would be the same thing. I could start, but instead of writing that, could I just put 4 to the third since I found that pattern? Okay, I'll scoot that over a little bit here. 4 to the third. Okay, and could this be then 100? Would be 100 to the third power, or 100 times 100 times 100. So my formula there could be n, whatever that is, whatever step number I'm on, I cube it, or to the third power. And I know 1 to the third power is 1, and I have 1 dot. 2 to the third power, 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And then 100 times 100 times 100, if you do the work there, you'll get 1,000,000. So again, it starts to get big pretty quick. And then number of dots, and this would just be n to the third power again, because I don't know what n is. So again, finding that growing pattern can be tough. We're thinking about, how many rows I have. You're thinking about, are they square numbers? And in this case, they end up being to the third power in the simplest form here. So trying to find those patterns, there are all kinds of them. This can be pretty difficult at times. So again, make sure you're getting this written down here. And this is just one type of growing pattern. And pause the video if we need to. In the last part today, we were writing some algebraic expressions to represent the situation, and then we'd be able to end up solving them if we got more information. So again, just understanding this, the way they're writing this and getting it into an algebraic expression, that would help us solve eventually for these phrases. In this case, Trey is I inches shorter than Ryan. Okay, so Trey is shorter, and they're going to say how much shorter is I, stands for how much shorter he is. If we know Ryan is 60 inches tall, Ryan is taller. So to find how tall Trey is, I would take the 60 inches that Ryan is, and Trey is I inches shorter, so I would subtract that I, because that's how many inches shorter he is. That's my variable. So 60, take away I, would tell you Trey's height. And the second one, 17 more than. We know more than means addition. So I have 17 plus, 17 more than. Product means multiply. The product of 3 and j means multiply 3 and j. Do not have to use a multiplying sign because we know 3 times j, if there's no sign, it means multiply. So 17 plus 3j would be my easiest way to write this algebraic expression to show what's going on in this situation. Again, make sure you've got all these things written down. These are kinds of the questions you're going to see come test time here in our algebra unit.